think it's important to give you a background of where Agile mostly comes from. And it comes in this bottom left-hand corner, internal IT projects. And I think it's the reason why I want to, they're different from consumer products. And to try to explain to you the difference, I think of Barclays Bank. They go to a nice software house and they ask them to build an internal system that helps them with processing credit cards. That is a piece of software that they're going to give all of their employees and force them to use. And that's different when Barclays Bank go to exactly the same software house and say, can you make Ping It? It's a consumer app that is going to allow our customers to be able to transfer funds to their friends. Now, the way that that software house approaches the project might still be under Agile, but there's a different focus on what they're trying to do. So the way Agile helps in those internal IT projects is the realistic. He's right. They don't know what they want. They can't define up front what they're trying to do, and so this iterative and try to come to a best product is the way to work. And you're going to get the maximum value out of the money by iterating, and it's up to the company then how much they're going to spend. But you see the point that there's a company that is putting their money behind it, so they have a vested interest in trying to find the right solution and trying to iterate to get that maximum value. When you're trying to create something for a consumer, the consumer's not got any vested interest. And so it's much more important. There's also, they're not going to be forced to use this product. So UX, the user experience, is now the key thing that you're trying to get, and that's where the value is in this and iterating. It's trying to find the best experience for the customer. So, and that tends to be required to be done a little bit more front-loaded than perhaps you'd be able to get away with when it was an internal project, because you only really get one shot to get a consumer to buy your product. When it's an internally mandated thing, you are going to use this, you can probably sit there every single day getting the guy to do it because they're paid to do it. So there is a different mindset and it's a different end goal of what you're trying to achieve. So if you're using Agile to create a new product that's going to be for consumers, so new product development, you are front loading. It does go a little bit against what we've just seen about this idea of Agile. You are going to have to spend a bit more time up front trying to get your user stories and your user experience right before you start the development process. But they're all going on concurrently, and that in itself is a bit of a lesson for your average startup. So if you're going to stay the same size team, the job that you do will be much more planning and design at the beginning before you really get to depth of the coding. And it could well be that you're going to need to then, as the project comes forward, you're going to, as you can see at the bottom of the graph, it's where the coding really starts to hit you. You're going to need more developers. So in an established business, there's no point getting all the builders on site on day one because they've got bugger all to do for a while. So it's important to realise that it's different. If you're doing new product development, that's different from if you're in a software house and you're doing one product for a single company. So this new product development, actually, you might have heard and read things about this water, scrum, fall idea, and there is a bit more of a standard processes up front, but the development is still being done in this agile scrum methodology. And then when the product's going out at the other end, yeah, it's back into a waterfall approach. As it tested, are we actually able to? Is it being accepted? And we've got to roll out the product, which is different when it's for a single customer who's going to roll it out within their own network. So I thought that was important to cover the effect that Agile has on what you're trying to do in new product development and startups. So the question comes, what has happened to the architecture during this time? Has something emerged, or have you got a plan? And these two images sum up the extremes. So looking at the code base, would it be like trying to pick a ball of string apart to try to work out what's done? Or have you still got a nice modular approach to your full system, so you'd be able to plug and play different bits in? So you've got lots of things that are going to affect that. Have you behaved like a group of hero programmers, or are you an effective team? Has someone actually had this long-term plan, and are you all sticking to it? And importantly, are you keeping track of all these hacks that you're putting in? I think a couple of other bits that do help are the code reviews and the coding standards, and enforcing them, and going back and looking at how you wrote something a few months ago and seeing if it can be improved. All makes it easier to have a much better structure to your architecture. And as I've just started to talk about with the Agile, the project management methodology that you're putting in, if you understand where it is, have you put in enough time into your planning up front so that you can have this nice big architectural goal that you're trying to achieve. So I'm going to move on to some of the mistakes the common mistakes, and I'll start off by the ones that I've made. I've got 3 different examples to try and cover. The first one is embarrassing. Dezrez 1, the first legacy product, when we first released it, had 10 characters for the first name field. Anyone called Christopher here? We can't store your first name in the database. Yay! And it gets reported back in a bug. And you go, well, in our original architecture, the way we had the system working is we were replicating data from our servers through into the browser, and we were having to keep the database schemas in sync. So the bug went in, it got reported, obviously virtually straight away, and we went, well, it's not that bad. They can use the full name field, and we'll come to it when we got more database changes. Forget about it. Okay. A few months go past. Well, we've got 100 customers now. It's a big upheaval if we make a change to the database structure. So we'll put them all in a big group and we'll do all the database changes together in a big go. 2 years go past. 300 and something odd customers. Oh, bloody hell. If we make that database change now, there's a risk we might drop the database on 300 odd customers. Oh my God, there's no way we're going to be able to do this. This is impossible. So we literally had allowed this tiny little thing. If we had done it at the beginning when we had found out, we still, 15 years on, we still only have 10 characters for the first name field. There are now hacks where people use the full name field, and you have to explain to everybody who ever writes code on this system that, oh yeah, if in this place you have to use the full name, and there in that place you can pull the first name field. It's embarrassing to go through, but that's what happens when you leave something grow. Okay, second example, which is from the new rewrite, and it's, I suppose it's the hindsight of having gone through this before. I want to send an SMS, so you get that as a requirement, and you just take a second to think about what you're being asked to do in the system, and actually what they're going to, because we've known about this before from where it's come back from a legacy rewrite, is actually eventually they'll say, I want to send an SMS through the provider of my choice. Now, if I get that as an architectural requirement, I am going to write the code in a different way than if it's just simply sending an SMS out. So it's important to take some time, step back, and have this grand plan about your architecture. And if you put some standards in that say you're trying to think of things in sort of like a replaceable, pluggable way, then doing the second requirement would be much easier than if you've got everywhere hard coded that you just send it to our one provider of choice. The third example I've got is just to say that you're probably used to arguing to the business about having time to go back to look at technical debt, because you do it for backups. Business never wants to spend any money on sort of like making sure they've got a proper redundant system and spending money on backups, and then it bites them on the arse, and then suddenly you get the budget and you can go and do what you wanted to do properly. Use that. That's a crisis. Crises are quite good because you can use it to get other things as well. So if you've ever suffered that problem where you know they didn't allow you to do something properly and it's bitten them, use it to go and argue the case. We're going to have the same thing. If we don't fix the 10 character problem, it's going to bite us in the arse. So you can use the crisis of when you've not been allowed to do the backups properly to get what you want, which is to go back and fix your technical debt. Okay, a bit more generic now. Agile does not mean no design. You really still need to have a plan. I'm starting to, you can see I'm going over the same ground. You need to have this big picture. Just because you're saying you're agile and you're going to iterate doesn't mean there isn't this big plan of what you're trying to achieve. And one way you can tell when someone's going down that line is when they've been using their proof of concept as the product, and I've been guilty of that. An important one of failing to design for maintainability. You are iterating. You are going to go back and look at this code again. It is not a hotel. People aren't coming around to clean up after you. You need to have this thought about making sure that you can go back in and understand what the hell's being written. We've just heard about if you can make the code, a simple line of code for checking the number of days in a month, making it much more readable, then someone else when they come in will be able to pick up where you left off and won't screw it up. Maybe a few of you know about use Basecamp, 37 Signals product. This is off their blog. I do completely agree with this one. The customer is not always right. You can't please everyone. If you try to do one thing for one customer, you're going to end up screwing up the bigger picture. So this is where having a plan and sticking to your big ideas really helps you decide, is this going in the right direction, or is this something very specific for this one customer that is a bit of an oddball, in which case don't do it. Avoid becoming sales-led. It's the same type of thing. Just because the sales guy comes back to you and say, if you do this, I'm going to earn some commission on this one particular sale, that doesn't mean it's going in the right direction for everyone. Marketing should be the lead, because they're the ones that are giving you, we can sell it to 400 odd people now. And at the beginning, it's important that you have this big design and this big idea of where you're going. Frameworks. They can be very useful, but they can also be a real problem. In one of our ancillary products, Dezrez PM, we chose to use a framework, you might know it, ext.net, and a new version came out, so we knew it was technical debt, we knew we had to do the upgrade, it got put into the backlog, and we took a month and we did the upgrade, and then a few months later we find out it's got a major memory leak, and they still haven't fixed it. So we are now dependent upon a framework, and the way we can use that framework is it's so wired into our product, we can't very readily take it out. So if we had structured and had an architecture plan about keeping the framework sort of like encapsulated, we could have swapped it to a different one, then we would have been in a lot better place. But we've actually got it so hard coded in, we are dependent upon it, and it's caused some problems. But it did give us a massive jump start at the beginning, so we got well ahead. Features do not equal a product. This is the idea that, especially when you're producing something for a consumer, it's the whole, how the whole product hangs together, it's the user experience, and just simply bolting on yet another feature isn't always going to give you the benefit. You need to consider how the user interacts with it as a whole. So think of the user journeys. Don't just add a feature, add a feature, add a feature. Just think about how it all hangs together and how the user would actually interact with it. Cut down features does not equal cut down architecture. Plan and get your architecture right for the big picture. So the analogy would be, you put all the footings and the foundations in for a house, even if you subsequently change your mind from a two-story and make it only a single story. But you need to have put in all the footings. It gives you the options later. I got this from one of our developer guys. I think he's obviously experienced this firsthand. Don't try and fix something if you don't understand what it's trying to do. And that comes back to having maintainable code. If it's maintainable, then most people should be able to understand what the code's trying to achieve. If you don't, try to understand fully what you're trying to do before. You'll do more damage than good. But please stick to something. There's we've used Durandal, and then Durandal was, it's not flavour of a month. Now you need to be on Angular. And now they've got Angular 2. And now they've got Aurelia. And eventually, we could have spent our whole time trying to upgrade to all the latest versions or all the next fad is. But at some point, you literally just have to, no, this is the one we're using, we're sticking to it. Because otherwise you'll never make any headway. But so eventually you do have to pin your colours to the mast. Okay, help. What's actually going to help you try to avoid some of these problems? You might have got from what I'm saying now that you need to have this long-term technical plan. Now the company will have a business mission statement and a vision statement. You should have your own for your product. You should have this overall goal. These are overarching sort of like ideals of what you're trying to do, because it will help you. No, that is a hack, right? Write it down, put it on the backlog. Make time to refactor and do it regularly. Go back and look at things, because you'll uncover the I didn't know type ones that were technical debt that you didn't realise. So you'll only know that you didn't know if you go back, and you'll be able to see the things that you've now learned. Don't reinvent the wheel. I think this is an important one. Quite often, us techies, we like to think, I could write that. So I've seen someone else who could do it. I'm going to write my own version. It will be better. Well, it might be. Is it really? Probably not. And they've already done it for you, so you can save you time and you can move on and write something that's of more value. So if there are services out there, Amazon Web Services and Azure, obviously great. There's loads of things that you can jumpstart using. But equally, design patterns. They're tried and tested. Why risk doing something new if there's a solution that works perfectly for you? I mean, obviously, if it doesn't work perfectly for you, fine. But if there's a standard solution available, use it. It's there for a reason. And identify these gold-plated requirements. So These are the ones where the business are asking you to do something and you know that there is actually a lesser version that you could do first. Split it up, put it into the two. They're trying to do, coders quite often get accused of, well, you could have finished writing this, why are you going back and trying to improve it so much? Requirements can be gold plated as well, so look for those and try to identify them and do the minimum one first, check that it works, and then you can always reallocate the time and come back to do the V2. Okay, object-orientated design. I'm a very strong believer that this is the best thing that you did as your computer science degree. Object-orientated programming principles really are the basis of it, that will keep you on the straight and narrow. So, you know, dependency injection, inversion of control, writing functions that have single responsibility. These are all the things that mean that you start to have code that's maintainable, or it's readable, and you start to have classes that represent a single sort of domain area, and so you can swap them in and out. At the top of the tree, you've got modules, and that combine areas of domain together to offer something that is of value. So the object-orientated design is a really key part, I think, for making sure that you have this long-term plan that means you've got maintainable code. So if you've got somewhere that's not working right, you can take it out and replace it with an alternative object. And what we've done with the Resi project that we're working on is we've actually gone to an extreme, well, supposedly extreme. We've gone for separating the front end completely from the back end. So we have built on top of a web API, and we are working towards a service-orientated architecture. So it's great. It means you can completely consider things in total isolation. You don't have to worry about how it's going to. You don't have business logic mixing things up. So I really do think that the service-orientated architecture is a key thing that will mean that your code will last a lot longer, and the product will last a lot longer. Because your front end, if you change something in that service, it doesn't matter. The front end will continue as long as it matches that same shape hole. It can replace with whatever it wants. And one of the ways to sort of get there is to start thinking of things in terms of commands. I've seen a lot of third-party developers who, when they've given me an API they want to integrate into our product, they've literally just given me a whole object and I can update anything on it and put it back. And I can't understand how they keep control of the business logic. So they've just given me CRUD operations, and it just doesn't make any sense to me, because what you really want to be trying to do in this sort of like in this API surface is you want to be trying to show the intention, what you are trying to achieve, what is it you're trying to do, not how you're going about it. So the example from Dezrez, which is selling properties, is you want an offer to be accepted. That's what you actually want to achieve. You don't want to change estate enum from 4 to 5. That doesn't mean anything. As a developer who would look at that API, you're wanting to try and fire a command that will achieve something, not how it's going to be achieved. So CQRS is sort of like goes a long way to this, is separating out the queries from sort of like firing the commands, and it comes back to this sort of like SOA, service-orientated architecture. If you do that properly, you suddenly have got an API that any third-party developer could either integrate with or pull back for themselves. So you instantly get integration with loads of other third parties without you having to do any extra work, because you've built your own product as this SOA. Reusable. It's a common thing to go when the coding you want code reuse. But you also want to be thinking about it from a business perspective. So if you can create these modules so that they have a particular job they do, you'll be amazed how you can rejoin together all these different services and create actually a slightly different product, so the business will have actual value. You can think about writing a service that is document storage. You'll be able to wire that into multiple different products, but you only actually have to have one that you write as your single service. And just to reiterate the importance of service-orientated architecture, this email has gone down as being like the point where Amazon started to dominate and become this sort of web services company. And you can see how important it was to them. They were going to fire you if you didn't actually follow this idea of being a service-orientated company. It also shows that Jeff Bezos doesn't know how to use a semicolon and can't spell imaginary words like externalizable. But it gets over the point. It was that important to the company, and this is where they started to build Amazon Web Services. So I am coming to a close now. I'll quickly go through the architecture that we've actually got for our Resi product. So this is the single page application, so this is the front end, and you can see it's communicating directly and everything is going through this web API. And we've chosen some frameworks and things to Durandal, Knockout, Require. We've gone for TypeScript so that we can keep our object-oriented approach to the JavaScript that's being generated. And we do, you know, there are other libraries we're loading in that will help, but Moment is the one I picked out on there. The back-end architecture is, I'm not sure if you can read it all. We're reusing all of the Microsoft Azure, many of the services that they've got. So this web API front end is then creating instances of things that Microsoft Azure allows us, these worker roles, queue managers, notification services. So they're already being written for us and we're just sort of configuring them. And that means we get instant scalability. We haven't had to worry about how we're going to scale. So our architecture that we decided to go with was that we needed to have this scalability built in, and the Azure framework really gives us that straight from the off. But we're not totally stuck on Microsoft things. We've got Elasticsearch and Redis. We even, when we're talking to the database, it's all behind Hibernate, so we can swap out and put a Postgres database if we wish. So it's all encapsulated away and we don't have to worry about it. So it's given us a very, well, hopefully a very modular structure, and we have had this case where one part of it wasn't working very well, and so we've changed the underlying code that we were doing. We swapped from, that's where Redis came from, we needed a faster way of having cache. So that's really sort of like the end of the talk. I'm hoping that I've got over to you this concept of technical debt and that you need to go back and fix it at the right time. I also hope that you put some structure to your code and you create a whole system with a big plan, an architecture. And the main reason, if nothing else, is architects get paid an awful lot more than bricklayers.